Question number 7 then. The alkene 3-methylpentoene, and it's drawn for you here as a structural formula. It exists as E and Z isomers. Draw the structure of Z3-methylpentoene. So it looks like this. So pent is 1, 2, 3, 4, 5 in a line. 1, 2, 3, 4, 5 in a line. And it's got a methyl group at carbon number 3. 1, 2, 3. There's the methyl group. 1, 2, 3, and at carbon number 2 it's got an ene, pent-2-ene. So let's see if I've drawn the Z isomer or whether I've drawn the E isomer. So what do? We look to the left of the double bond, and then we find the atom with the highest atomic number. Hydrogen has got an atomic number of 1, carbon's got an atomic number of 6. So this group here would take priority because this carbon to the left of the double bond has got a hydrogen with an atomic number of 1, a carbon with an atomic number of 6, so this group takes priority. So remember that group. On the right hand side, let's see which group takes priority. We've got a carbon joined to the carbon of the carbon double bond, and we've got a carbon joined to the carbon of the double bond. So we've got 2 carbons joined here, each with an atomic number 6. So we carry on further down the chain. Joined to this carbon, we've got hydrogens with an atomic number of 1. Further down the chain here, we've got this carbon joined to hydrogens, but also joined to a carbon here with an atomic number of 6. So this group takes priority. So this group and this group are the 2 that takes priority. They're on the same side, both on the top of the double bond, so it is indeed Z. Name and outline a mechanism for the formation of 3-bromomethylpentene from the reaction of this with hydrogen bromide. So you need to draw this and hydrogen bromide. What kind of mechanism is it going to be? Well, it's going to be electrophilic addition. I'll explain that in a minute. So now we've got the carbon-to-carbon double bond attacking the H of the HBr. The reason is that's slightly electronegative, so it's going to have a delta minus, that's going to have a delta plus. The electrons will attack the delta plus here. The H is going to bond onto one of these 2 carbons. We'll discuss which one it bonds onto in a minute. The Br breaks off and forms Br minus, and there'll be a pair of electrons from the double bond on the Br minus. Which one does the H bond to? Well, if it's the major product, and we're going to assume it's the major product, we'll check that out in a minute. If it's the major product, it goes onto the carbon that's got the most number of H's bonded to it. So this carbon has got 1 H bonded to it, CH. This carbon has got no H's bonded to it. It's got carbons bonded all along to it. So this H will go to this CH that's already got 1 H bonded to it, rather than this C which has got no H bonded to it. So it's going to form CH2. And then this carbon, because the double bond's broken, so there's a CH2 and a single bond here now, and this carbon now has only got 3 bonds, so it's short of an electron, it's short of a bonds and electron. It becomes plus. The Br minus attacks that plus with a lone pair of electrons, so the Br will join onto here. Let's see if we made the right choice by choosing the major product and the H joining onto this C rather than this C. So the Br, what is on carbon number 3? So we're going to end up with pentane with a methyl group at carbon number 3 and a Br at carbon number 3. We're going to have 3-bromo-3-methylpentane. 3-bromo-3-methylpentane. Yes, we made the right choice by choosing the major product and the H going onto this carbon rather than this carbon. Electrophilic addition, why? Because this is an electrophile, it's an electron pair acceptor, it accepts the electrons from the double bond. This is an electrophile, and I've got 2 reactants forming 1 product, so they're adding together. Explain why this is formed in the reaction, so why this is the major product rather than 2-bromo-3-methylpentane. It's because this C with a plus is called a carbocation, and if you count the number of carbons off that C plus, it's got 1, 2, 3. So it's called a tertiary carbocation because it's got 3 carbons bonded to the C plus. A tertiary carbocation is stable, more stable than the secondary carbocation, which would have a carbon with a C plus joined to 2 carbons either side of it, which is in turn, a secondary is more stable than a primary carbocation that's got a C plus with just 1 other carbon joined to it. So this tertiary carbocation is more stable than a secondary carbocation. Had the H bonded to this carbon, and the plus being here, then if the plus had been on this carbon, then the plus on this carbon would have been a secondary carbocation, because this C plus would have had carbons either side. So your answer is that 3-bromo 3-methylpentane is formed from a tertiary carbocation, which is more stable than the alternative, which is a secondary carbocation, which would be the minor product.